So probability techniques use random selection to create the sample. This gives you a picture of the diminishing returns. The rule of thumb for selecting a sample for sample size is that you want to get to about the 5% accuracy results. So here's the rule of thumb. You want to get to about this level. And you can see that as that sample size goes up, your accuracy level doesn't go up nearly as much. It would take a lot of resources and a lot of effort to get a sample size that's that large, over the 400 to the 6400, but your accuracy doesn't go up that much. That's what I mean by diminishing returns in accuracy. And accuracy is about how well the sample represents the population. That's what we're talking about here. How confident can we be that the sample represents the population? In probability sampling, you can calculate that accuracy. And this is true. This sample size is true. It provides this level of accuracy in about every situation. So it depends on your population size. If you know your population size, for instance, I know that about 1,200 first-time college students come into the college each fall. Well, if I want to run a survey and I want a sample of those 1,200, and I want it to be representative of those 1,200, I still only need about 400 people. I only need to talk to about 400 people in order to know that I will be able to have this level of confidence that my sample represents the population. When we ran the Community Attitude and Awareness Survey, we're looking at the population in a 5-county area. So we're looking at about 95,000 people in that. No, I take that back. We're looking at about 295,000 people in that 5-county area. I still only need to talk to about 400 of them in order to achieve this level of accuracy in knowing that my sample represents the population. And the reason this is true is because of probability theory. I can calculate that. And that's what randomness, a random selection, allows us to be able to say. So what does this accuracy rate mean? Well, here are some definitions down here for what that accuracy rate means. What that 5% tells us. Given a population where we have about 45% men, if we had a sample size of 400, then we can know that the population, or that the sample, will have about 40 to 50% men, plus or minus 5%. That's what that 5% tells us. The confidence interval, which is also called the margin of error, is plus or minus 5%. This is what that 5% means. That's the confidence interval. So in this other term, this confidence level is 95% at that 5% margin of error. What that stands for is the degree of certainty that you can have that given, let's say, 100 samples, if you know that the population has 45% men, given 100 samples, you can be 95% certain that these 100 samples of 400 people will be 40 to 50% men plus or minus 5%. That's what the confidence level tells us. Okay, so probability samples are important because we can calculate how representative the sample is of the population. How do we get there? How do we create a probability sample? Through these 4 random sampling techniques. And the key word here is random. For the simple random sample, as I mentioned, simple random sample is just like pulling a name out of a hat. It's like a flip of a coin. Each and every member of the population has an equal chance of being selected. Now, in order to do that, you have to know the population. In order to have a simple random sample, you have to know everybody in the population and have access to them. You do not want to use a simple random sample if you need to have certain subgroups represented in the sample. You can do that in other ways. For instance, through stratified random sampling. In this case, we want to make sure that certain subgroups in the population are represented. And again, you have to know your population in order to be able to do a probability random sample selection, or you have to have access to your population. So for stratified random sampling, you first group the population into certain subgroups that you're interested in. And then you select from those subgroups to create the sample in the same proportion that those subgroups exist in the population. It increases the likelihood of the representation for the sample to the population. So it increases your external validity. So here's an example, this community attitude survey. For this community attitude survey, we wanted to look at everybody in the college's service area. And if you recognize this part of the geography of the state of Michigan, you'll notice this is the northwest corner of the Lower Peninsula. Here is Grand Traverse County in dark blue. And we also have Leelanau County, Antrim County, this is Antrim County, Kalkaska County, and Wexford County, and Benzie County on this side. It's actually not a 5-county service area, it's a 6-county service area. So we wanted to be able to generalize the findings of the survey to everybody in the college's service area. So it's a 6-county service area. So in order to do that, we had to know the population of those counties, which, as I mentioned, was about, actually, if you look down in this corner, it wasn't too, it was 198,000. Was the total population in that 6-county service area. But I only needed a sample of 400 in order to be able to generalize to this 6-county service area. But in a basic random sample, though, the problem with that is that, you know, in drawing out of a hat, we could have had everybody all those 400 people could have been from Antrim County. I mean, if you're just drawing out of a hat, that's the way basic random sampling works. They all could have been from Antrim County. Well, we didn't want that because having a sample of everybody from Antrim County would not be very representative of the population. So we stratified the population. And out of that 198,000 people, we know that 12% are from Antrim, 9% from Benzie, 44% from Grand Traverse County, 9% from Kalkaska County, 11% from Leelanau County, and 16% from Wexford County. So we broke down the population by county. We stratified it by county. And so we got the proportion that each county contributes to the total population. We want our sample to reflect that by county. And so we make sure that the 400 people in the sample, and this is an N of 400 down here, are in proportion by county as they are in the actual population. That is stratified random sampling. So we tried to get close, but the entire sample was made up of 45% from Grand Traverse County, and so on and so forth. That's stratified sampling. This ends this part of the module's presentation. Please move on to review the next part